Hi everyone. 4 o'clock crept up on me a little bit there, but good afternoon. And we're on day 9, so we'll pick up right from where we left off yesterday in just a moment. I'm just making a couple of notes to myself about what I'm going to talk about today, and then we'll get on from there. So I'm going to talk about scripting today, but the first thing that I wanted to do was just come back to the end of yesterday when we were looking at grep for the second day, and we were using grep to pull PubMed IDs out of the Uniprot file that we were looking at last week. So we'd written a grep command which found those lines in the file and then pulled out just the bit that we wanted from the file. So just pulled out the PubMed ID itself through a couple of, so we had to do a couple of greps to get that far. So we had to do one which just pulled out the PubMed ID with a little bit of the text in front of it, because to make sure that we were getting the right numbers essentially out of the file. And then we piped that into a second grep, which just retrieved the numbers from those little bits. So that just got us back the numbers that we were interested in. And so let's go back to our VM. Here we are. So you'll see that I'm back in the week 1 directory here. So I'm back in the same place as I have been for the last couple of days. I've not actually done very much in that week 2 directory, but that's mostly because I'm making use of this Uniprot entry. We did the first grep we did. So first of all, we tracked down the RX line in the RX lines in the file, and then we used that to write a match for our PubMed IDs. So PubMed equals, and then one or more digits to get us back the PubMed equals, and then the identifier itself. So that will return us those bits, and then we fed that into a second grep. And the second grep just pulled out the numbers. So another, again, using Perl regular expressions, we only want to return the matching portion, so that's the -O option, and then we just want the digits this time. And that will give us the PubMed IDs. And then what I left with was saying that I would figure out a way to turn these PubMed IDs into URLs so that we could actually go and retrieve the PubMed entries much more straightforwardly than having to copy and paste each of these IDs and search them on PubMed. And I think there was one suggestion in the comments on yesterday's video, which is absolutely which would also work. You could actually use Perl itself to do this but then I would be teaching you how to program in Perl. I did use sed. So sed is a command, it's SED, which stands for stream editor. So sed is a way of editing an input stream, so of making changes to an input stream. So it's a relatively clever tool that's quite difficult to get to grips with, and it's not a tool I use very often, but I figured out a way that we could do this with sed. So essentially what we want to do for each of these lines as they come out of grep is we want to add a prefix to them to turn them into a URL, so a prefix that is the URL that PubMed uses in front of the IDs for each entry in the PubMed database. So in order to add a prefix using sed, And I'm afraid this is going to span 2 lines. What I'm going to do is I'm going to escape my new line. So I'm just going to put a backslash, and the backslash says to bash, so it says to our shell, ignore whatever comes next. So don't interpret what comes next. Usually, if you hit the enter key, the shell interprets that as being, I finished writing this command now, but the backslash says, well, ignore that new line and I want to continue writing this command. So that gives me this little angle bracket on the left hand side of the screen, and that tells me that bash is continuing to listen for my input. So it's continuing to try and interpret what I'm typing in at the command line rather than just executing what I've put in so far. So I'm going to put a pipe. So that takes the output of our second grep and pipes it into the next command. And our next command is going to be sed. So sed, stream editor, sed. And sed is like grep with the Perl regular expressions turned on. Sed is very Perly in its syntax. And I learnt to program in Java. But I very rapidly forgot all of that because I don't really like Java. And I really cut my teeth on my first kind of bioinformatics research project using Perl. So I have this kind of muscle memory for the syntax of Perl, and it doesn't offend me too much. But I know a lot of people find it really quite ugly, which is fair enough. So what we're going to do with sed is we're going to edit our stream. That's what it does. And we're going to make a substitution. So we need to type S at the beginning of our little script that we're going to write. So this is a little one-liner that's going to get us to edit the lines as they come out of grep. So we're going to edit, and we want to do it at the start of the line. So that's our caret character. Okay, so the same as in grep, this little hat, this caret, means do this at the beginning of the line. So we want to substitute the beginning. So the S means substitute, and then the forward slash. So the first forward slash is, this is the thing that we want to substitute. So we want to substitute the beginning of the line, and now after the second forward slash, we want to put the thing that we want to substitute it for. Okay, so we want to substitute the start of the line for a whole bunch of text, and this is where it gets ugly. Okay, so HTTPS colon and then 2 forward slashes, same as a regular URL. But if we put a forward slash here, sed is going to interpret that as being the end of this block, and we don't want that, so we need to escape the forward slash with a backslash, and this is where it really starts to get ugly. So, and then we need a second forward slash, so again we need to escape it with a backslash. So backslash forward slash backslash forward slash, drawing little mountains, and then it is www.ncbi.nlm.nih.gov, so the URL for the standard URL for the NCBI, where PubMed is hosted, where BLAST is hosted, and various other things besides. Then we need another forward slash, so that's backslash forward slash to get another forward slash, then PubMed, and then finally one more forward slash to separate that from the PubMed identifier. So again, backslash forward slash. Now we need to finish this pattern, and to do that we need an actual forward slash, so this time not escaped, so that's a forward slash, and then finally we close our quotes, and that's it. And it looks really ugly and not very elegant, but it does work. He says, confident that this is actually going to work. Yes, there you go. See, so it has taken the results of grep, and it's changed the beginning of each line and added in that URL stub at the beginning of each line to turn the 8-digit numbers that were coming out of grep into URLs. And now in the terminal, because the terminal in Ubuntu is like a first-class citizen, it's part of the operating system. These are all, if you hover over them, you see they are clickable links. It's not as straightforward as just clicking them, I found out. You have to right-click and then go open link. And but it will open the link in your browser. So this has opened Firefox for me, and it's going to that that paper for me in my browser. So this does work really nicely to take those numbers that we got out of our PubMed file and turn them into links, which is quite neat. That's all right, really. You could even use wget to go and get these entries in some way, shape, or form. You can also see this is a paper about ACE2, somewhat reassuringly. So it does look like we've found the right PubMed entry as well, because this is clearly is a paper about ACE2. And we could open any of these URLs, and hopefully they will all be papers about ACE2. So I'll just open one more just to prove it. There you go. TPM-RSS2 and Adam17 cleave ACE2 differentially. Excellent. Okay, so that was a little exercise, and hopefully the way that has been solved is relatively instructive for everybody. So I'm going to move on to the topic of today, and the topic for today is scripting. So I'm going to begin to introduce writing some shell scripts, so some command line scripts, so that rather than just executing a single command at a time, we can batch a bunch of commands together into a script and use that to execute a set of commands all in one go. So I'm going to talk a little bit about scripting, because I'll start by drawing some stuff out, and that's really only an excuse to show you the picture of the day, let's be honest. Just going to sign into my Surface. Here we go. Right, okay. So let's skip across to the whiteboard. There we go. So there is Jacob's picture today. It's a chick, and this is a disco ball, obviously. The mind of a 7-year-old is a marvellous thing in many ways. He did want me to show you the he wanted me to show you the full colour version, because the Surface whiteboard app has these rainbow pens, which Jacob very much likes using, and the web app doesn't interpret the rainbow colours properly. So he wanted me to show you the original and best version of this picture. So there you go. There's the original version there with all of the rainbow colours in their full glory. I'm sure you'll agree that the web app of Whiteboard does not do it justice. Okay, so onwards and upwards. Right, so we're going to talk about scripting, and essentially a script in the end is a text file. Right, so it's just a file on the disk which has some text in it. That text takes the full week and a bit. Okay, so lots of lovely comments about the picture today. I will relay those to Jacob and make sure that he knows that you're all very keen on his picture today. Right, okay, so text file. Yes, a script is a text file, and the text in the file is a series of commands that can be interpreted by bash. So there's a lot of potential when you're writing a script that if you make some errors that the interpreter can't understand, then it's not going to be interpreted correctly. So we have to be relatively careful when we're writing scripts that they make sense to our shell, that they make sense to bash. But in the end, they are just a text file. We tend to call them, we tend to name them something.sh. And again, with our command line environment, remember that the extensions on the files don't mean anything to the command line. They're for our purposes, so that we understand that this is a script and not just a normal text file. They also have some special features. So there is some things about text files that are actually scripts that make them scripts. And the first thing is that on the first line of your script, you have to tell your system, you have to tell Linux how you want this script to be interpreted. So you have to point your command line environment at the correct interpreter in order for it to understand that this is a script. And you do that with what's called a shebang line, and it's called a shebang for reasons lost in the mists of time, but it starts with a hash character and a bang, or an exclamation mark. So hash bang or shebang. Okay, so that's how it begins, and then you point your you point it at the right interpreter by telling it where on your system that interpreter lives, which is a fully qualified path to your shell, which in our case, if you remember, is called bash, and that lives in the /bin directory, which if you remember right back to, I think last Tuesday, when I was talking about the structure of the file system, you'll remember that the root of our file system has lots of directories underneath it. One of those directories was home, which is where our home directories live, and another one which I talked about a little bit was bin, which is where the binaries live. And so bash, which is a system binary, it's our shell interpreter. It's actually what's running all of the commands that you type in at the command line, lives in /bin/bash, and you have to tell your script that that's what you want it to be interpreted with. So that goes on the first line of your script. That's kind of the first special feature of a script. The other thing about a script that allows us to run it rather than it just being a text file is it has to be executable. Okay, so I'll try and explain what this means in a minute. I'll go back to the command line and I'll show you what I mean by executable. Actually, one of the nice things about using our share directory for this is that by default, all of the files in that share directory, because of the weird way that the share directory is set up, in order to be able to share files between our VM and our host operating system, all of the files in our share directory actually already are executable. So we're not actually going to have to do anything to make our files executable in this instance, but on a normal system you would. So I'm still going to talk about what executable means and how we work with it, how we set a file to be executable if it isn't already. Okay, so those are the special features of a script, and I'm going to show you an example first, and then talk about these special features in a little bit more detail. So we're going to go back to our command line, back to our VM, which is here. For those of you who are struggling to access, to get to the PubMed, just make sure that you've got the URL as it is there, because I know the NCBI URL is long and tedious, and it's quite easy to make typos in it. It's also quite easy with this sed thing to miss out some of the forward slashes because they're so blooming hard to type correctly. So yeah, it can be a little bit tricky to get that right first time. Okay, so scripting. I'm going to go into back into our week 2 directory. So I am going to work in week 2 for the rest of today. So I'm going to cd into our week 2 directory. So to do that, I'm going to use ... to go up one level into our share directory, and then / week2 to go back down into our week2 directory. List the contents, check that we're in the right place, just make sure that we are where we think we are, and then I'm going to write a script. So I'm going to do that using nano. Nano, if you remember, is the command line text editor that we used last week when we were starting to look at putting contents into files. It takes an argument, which is, or it can actually take a list of arguments, which are the files you want to edit with nano. In this case, we're going to create a script called test.sh. Okay, so we're using that .sh extension so that we know in the future that this is a script. Okay, when we come back to this in 6 months and we wonder what's in that file, we know at a glance that it's a shell script. Okay, so this opens a new file. It's empty to begin with because we've just created it. So Nano has just created it for us. And what we need to do is the first thing that I talked about on the previous screen. So we need to put in our shebang line. So the shebang starts with a hash, which can be a pain to type with a Mac keyboard, and I might need to open a text editor and see if I can type it in there. Accessories. Where is text editor? LibreOffice will do. Bit heavyweight just for a text editor, but there we go. So I should be able to, hopefully I can type a hash in there. Now you see hash on my keyboard isn't working, which is a pain. I got it to work before, but now it's not working. I'm not entirely sure what to do about that. Paste it off the internet. Let's just hack around a little bit. The other thing I could do is reset my keyboard settings so it's a PC keyboard layout, and then it's fairly easy to find. Right, so hash character £. Just show me the hash. There it is. Click on it. Oh, new statesman article. Thank you. I just want your character. That's all I want. There we go. Copy. Well, that was fun. Paste into the terminal is a middle click. There we go. So there's my hash. That was a bit of a faff, wasn't it? So Alt # for me didn't work, I don't think. I'm just going to check. No, it's not working for me. So I've pasted it in from the internet because that's one of the things with VMs and keyboard settings. What a pain. So sorry about that. Anyway, right. So hash bang or hash shriek or hash exclamation mark or however you want to describe it. I will refer to it from henceforth as a shebang. /bin/bash, and that says when we execute this file, that tells our command line that's the interpreter for all of the commands that follow in this file. So this is what's called a bash script. Okay. If on the other hand we wanted to execute this with a different interpreter, we could point to that different interpreter. So if we wanted to use Perl, if we wanted to write a Perl script, then you would put user bin Perl, because that's where Perl lives on our system. So you can write a Perl script, and as long as everything that followed was valid Perl syntax, then when you tried to execute that file, it would be interpreted by the Perl interpreter. But we're writing a bash script, so we're going to do bin bash, which is where bash lives on our system. Okay, and then in the body of the file, we can then type just commands that we would have typed anyway. at the command line, and they will be interpreted. So we can do echo hello world, and that will be interpreted. And you see, as we do this, Nano is understanding that we're writing bash, and it's colouring things in for us in meaningful ways according to how it understands bash, because Nano's being a little bit clever here. So it's coloured in the thing in quotes, it's coloured in yellow because it's in quotes. Echo, it's coloured in blue because it's a command. Okay, we could run ls, and ls will be run as it would have been if we'd run it at the command line, and we can run how about sleep. Sleep is a command which does exactly what you expect and puts the system to sleep for as long as you tell it to. So we're going to tell it to go to sleep for 5 seconds, and then we're going to echo goodbye. Okay, so that's it. That's what we're going to do. We're going to echo, we're going to list the contents of our present working directory, then we're going to sleep for 5 seconds, and then we're going to say goodbye. And that's what this script is going to do. And it executes each of those lines in the order that you type them. So it's what's known as a procedural program. So it executes the lines in the order that you've written them. It's not looking for any special sort of start command or anything which is going to start to execute these lines in any sort of weird order. So it's quite easy to understand as a program. So we're going to write that out. So Control O to write to our test.sh file that we've just made, and then Control X to exit. And that's our script. That's it. That's all of the contents that a script needs to actually function as a script. We're going to look at some more complicated features of scripting. We'll do a little bit today and a little bit tomorrow. I think we're going to look at some more complicated things that we can do with scripting. But this, in essence, is a useful, hopefully useful script. So yes, we're going to do those 4 things. In order to do this now, in order to run this script, we need to be able to execute it. And that means it needs permissions for us to execute it. And we've seen permissions on files. I just haven't really talked about them so far. So I'm going to talk about permissions now, and I'm going to do that by showing you the results of ls-l-h, which is the long listing format of ls. And one of the things that this long listing format gives you is the permissions that a particular file or a particular directory carries. So the things that you're allowed to do with this file. And that is, the permissions are determined by this string here at the beginning of the file. Okay, so this string of characters, there's 10 characters here for every single file and directory. That string of characters tells me about the permissions of this file. So I'm just going to explain that. So I'm going to write this out and explain how it works. So okay, let's change screens. Here we go. So let's get rid of this. So when we do ls-l, we get the file. So the file name's over on the left-hand side, on the right-hand side, sorry, of the screen. And on the left-hand side, you get this permission string, and it's 10 characters long. So in our case, what we saw was dash rwx dash dash dash. Okay, I'm just going to refresh whiteboard because it's never going to keep up with me all of the time. Everybody sees my login again. Right, there we go. So Come on, whiteboard. Almost ready. Always takes longer than expected. It suggests to me that it doesn't expect that it should take long enough. Right, okay, so here we are. Good. So ls-l, we get the file name over on the right hand side and the permission string over on the left hand side. So this permission string, as I said before, is 10 characters long. Okay, so we can split it up into little pieces. So I'm going to draw some red lines to split it up. So you get the first character is the first block. Then you get a set of 3. Then you get another set of 3, and then a final set of 3. Okay, so the first one there, that is either D if this file is a directory, or hyphen if it's not. Okay, so that's your first one. That first character tells you whether or not this file is a directory. Then the next sets of 3, the next 3 blocks of 3 are the permissions that are granted to 3 different sets of people. So the first block of 3 is the permissions granted to the owner of the file. The next block of 3 is the permissions given to the group that owns the file. And then the third block of 3 is the permissions given to everybody else or others. And actually I should say for owner, we usually refer to the user. Okay, so we've got user, group, and others. And the permissions, you get these three things that are set for each of those things. So they're either a dash, or the first one is an R for read. R equals read. So if you have read permissions, it means that you can, as the name suggests, read the contents of that file. So if your permissions were just R, and then, so if it was R dash dash, so if this was R dash dash, that would mean that you had read-only permissions for that file. W, I'm sure we can all guess, is write. Okay, so if you have a W, then you have write permissions. So usually you wouldn't have write without read. So if you had R W dash, that means you have read write permissions for that particular file. And then X, and I'm sure you've all figured out where we're going with this, X is permission to execute the file. So RWX gives you permission to read and write and execute the file. So final question is, how do I know who the user is, who the group is, and who others are? Okay, so the user is the owner of the file. The owner of the file is also shown in the long listing format of ls. Let's see if I can get that to actually write. No, it's not going to catch up. Never mind. Okay, so here we've got the permission string, and then a number, which is always 1 for a file, but would tell you how many files are contained inside a directory if it was a directory. Then the next thing is the owner. So in this case, our script at the bottom here, test.sh, is owned by root. So it's owned by a user called root. Okay, that isn't me. My user is Simon. That's my username. So I don't own this file. I'm not the owner, which means that any of the permissions that are applied for the owner here do not apply to me, because I don't own this file. Now that's extremely unusual. It's very strange for you to have created and written a file but not own it, and that's a quirk of working in this share directory. So in a second I'm going to go and do this in my home directory, and I'll show you how it would normally work on a normal file system. So this file's owned by the root, and that's not me. It's also owned by this group. So the second string here is the group. So this vbox-sf group, or the VirtualBox shared files group. And if you remember, one of the things that we did on installation day back on Monday last week was we added ourselves to that group, that vbox-sf group. And that was so that we would have permission to create files and edit files in these directories. So we are a member of the vbox-sf group, and just to confirm that, you can run the groups command and it tells you the groups that you're in. So by default you're in a group that's got the same name as you. I'm also in all of these other groups, but importantly I'm in the VirtualBox shared files group. So the group permissions, the second RWX here, those permissions do apply to me. Okay, so I inherit those permissions by virtue of being a member of this vbox-sf group. So that means for this test.sh file, I have read, write, and execute permissions for this file. So I am allowed to read it and write it, and we've already seen that because we've done that, both of those things in Nano. But I'm also allowed to execute it. And that's the most important thing for being able to run a script, is that you're allowed to execute it. Okay? So that's the key point here. We have the permissions that we need. Now, very quickly, I'm just going to go to my home directory. So cd with no arguments takes me back to my home directory. And I'm just going to show you how this works. Before we execute that test script, I'm just going to show you how this works on a normal file system, and how we add execute permissions to a file should we need to. Okay, because under normal circumstances you wouldn't already have execute permissions on a file. So I'm going to create another script. I'm going to call this one test2.sh, and I need to put my oh no, I need to get my hash back. Okay, you'll all be jumping ahead of me again. Bear with me a second. Exit. Yes. Okay. Nano. Share. Week 2. Test. Okay. Just move my cursor. Highlight the hash and then exit, and then there, and now hopefully there you go. Right, fine. Bin bash. So it's a script again, so we need our shebang line at the start, and all I'm going to do in this script is echo hello world. Okay, then so just one command in this one. So I'm going to exit, and as I'm exiting I'm going to save that script. Now if we do the long listing here, -l-h, we will see that this file that we've just created, the permissions, the owners and the permissions and everything are different to the file in our shared directory. So, and this is the default settings for most file systems. When you create new files on a Linux file system, this is how files are generally created. So this file test2.sh, in fact, let's just get the listing for that one thing to get rid of all the others and avoid any confusion. Okay, so test2.sh is owned by me. Okay, so it's owned by Simon, and it's in the group Simon. So both the user and the group both apply to me. Those permissions apply to me. So this file is read-writable by the owner, by me. It's read-writable by the group. And again, I am the only member of the group Simon, and that is by default on a Linux system. When you create a user, you also create a group which has the same name as that user, and the only user in that group is that user itself. So these group permissions here are no more permissive than the user permissions. That's not allowing anybody else to read and write this file. And then everybody else, so others, everybody else on the system has read-only permission for this file. So they can see that the file exists, they can read the contents, but they can't overwrite those contents, they can't change them. And they can't also, if you don't have write permissions, you can't remove a file. So no other user on this system can come along and remove this file because they don't have permissions to do it. But also, it's a script and we don't have permissions to execute. So we have no permissions to execute this script at the moment. There's no X in this permission string. So in order to be able to execute this file, we need to set those permissions. We need to give ourselves the permission to execute this file. And because we own it, and because we have write permissions, we're able to set the other permissions on this file should we want to. And there's a command for doing that, and that command is chmod, or change mode. In chmod allows us to change the permissions on any file or directory that we have write access to. So as long as we can write to that file, we can change its permissions. And that's what we're going to do here. So the first thing I'm going to do is I'm going to go back to my whiteboard. 1 second. Because I want to talk about the way that we determine permissions. Okay, so let's delete this and this and this, and refresh so it catches up with us. Dear oh dear, being particularly laggy today. Okay. Come on. Okay, so the command for chmod takes the first argument for chmod. It takes 2 arguments. The first is how you want to change the permissions. The second is the file that you want to change the permissions of. And the argument for how you want to change the permissions takes 3 bits. Okay, so the first bit is who do you want to change the permissions for? So that's either, it can take 4 options. So it's chmod, and then it's either that you want to change the permissions for the user, U, for the group, G, for others, O, or for everyone, A, for all. Okay, so that's the first character. Then it's whether you want to add permissions or subtract permissions, so a plus or a minus. And then whether you want to add or subtract read permissions, write permissions, or execute permissions. Okay, so what we want to do is we want to add execute permissions for the user. So in order to do that, we would write chmod we go chmod user plus execute file name. So we're saying we want to, for the user, we want to add execute permissions. Okay, so let's do that. So chmod, so for the user, we want to add permission to execute this file, and the file is test2.sh. Okay, so that will add execute permissions for us to this file. This will have 2 effects. So the first effect it will have is it will add an X into our permission string at the 4th position, because that will tell us then that the user has execute permissions for this file. It will also change the name of the file green in the results of our ls, and that green colour, which I said I would come back to in the future, that green colour is saying that this file is executable. That's what that green color means. Okay, so there you go. We've executed our chmod. As usual, we've not been given back any feedback from the system. But if we do ls-l-h, then we will see that test2.sh has gone green, as I predicted, and also that X has been added for the user, but not for the group and not for the for others, because we didn't ask for that. Okay, we could also use chmod to remove those write permissions from the group. So g-w will remove the write positions from the group. Test2.sh, so that, and that can, if you're really concerned, if you've added other users to your group, or the file is owned by a strange group and you're not necessarily 100% sure who's in it, whether you really want them to be able to overwrite your files, then this can be a useful thing to do. Again, no feedback from the system, but ls-lh shows us that W has now disappeared. So our permission string now, let's just list test2.sh. That permission string now, instead of being what it was initially, which was -rw -rw -r is now -rwx r-r-r. So the user has read, write, and execute permissions, and everybody else just has read, doesn't have write or execute at all. But that means I can now execute this file. So I now have permission to execute this file. So this is an executable, and it works like every other executable. So it works like ls, and it works like cd and cat and all of the other executables that we've been using. The only difference between those programs and this program is those programs are on what's called your path. And I'm going to talk more about the path tomorrow. I'm not going to talk about it I'm not going to do any more about that today. I'm just going to mention that it exists, and I'm going to talk about it in more detail tomorrow. But programs on your path you can execute just by typing their name. This program isn't on our path, which means we have to tell bash exactly where it lives on the file system. So we have to execute it using the full path to the file, either an absolute path or a relative path from where we currently are on the file system. So we can do it with an absolute path. So home Simon test2.sh. So that is a fully qualified path to where the executable lives, and then my interpreter knows where to find it, and this will run. And if you remember, the only command that we put into this file was echo hello world. So when we run this, it's like running that one command, and echo world is hello world is echoed back to us at the command line. Okay. The other way that you can do this, and a slightly quicker way of doing it, rather than giving our interpreter an absolute path to where the script lives, we can give it a relative path. And a relative path can be done just with a /. So you can say in my present working directory. So in my current working directory, which is what the dot means, there is a script called test2.sh. There's an executable file called test2.sh, which I want to run. And the // is what then allows you to run. It's telling the interpreter where that executable lives and making sure that it's able to run it. So again, that will work. If we just typed test2.sh and tried to run this command, it will the shell will tell us that the command can't be found because it doesn't know where to look for it. And as I said, I'll talk more about the path tomorrow and what the path means and how we deal with that. But that's because our current working directory is not in our path. So the interpreter bash doesn't know where to look for the script. It doesn't know where to find it. So you have to tell it explicitly where to find it, either with a fully qualified path to it or with a relative path using /. Okay, so back to our slightly longer script that we wrote before. So I'm going to cd back into share, and week 2, ls pwd, just to check that we are where we think we are. So there's my test.sh file. Now remember that like the scripts that we just created in our home directory, this one actually is executable without us having to do anything to it, and that's because it's in that share directory. So if you're not working on a VM or in a shared directory between a VM and a host file system, you will have to change the mode of this file, so change the permissions on this file to get it to execute in the same way that we did with our script in our home directory. So I don't have to do this, but doing it doesn't affect anything. It doesn't change anything. So chmod u plus x and then the name of your file will add execute permissions to the user of that, to the owner of that file. In this case, I already had those execute permissions. So in that case, this hasn't actually done anything. It's not changed the permissions of that file. Sorry, not A, L. So you can see that the permissions are still exactly the same as they were before. Nothing has changed. And actually, because this file is owned by root, adding user permissions for this file wouldn't make any difference to me anyway, because I'm not the root user. So actually what I would need to do is add group permissions to execute. So g plus x to test.sh. In order to add those permissions to the group, because I only have permissions over this file by virtue of the fact that I'm in the vbox.sf group. Okay, so again, that isn't actually going to change the permissions on this file, because I'm granting myself permissions I already have, so it doesn't change anything. And now to execute, we do ./test.sh. Now, can we remember what's in it? What's in it is there's an echo, and then it's going to list the contents of our current working directory. Then it's going to sleep for 5 seconds, so it's going to wait, and then it's going to echo something else, and then it's going to finish. So we've got a little bit of a built-in delay in this script, which should hopefully mean that it doesn't return its results immediately. So off we go. There you go. So it's echoed, it's listed, it's waiting, sleeping, and then it says goodbye. You'll notice that this worked exactly as it would have worked at the command line, except our colours have gone in the results of ls. And that's because we're running it from within the environment of a script, and it's not able to add those colours to the output in a straightforward way. So we don't get the colours, we just get white. For most purposes, that's fine. And actually, ls is not something you will commonly do within a script, at least not just to print those results to the screen anyway. So it isn't the end of the world that you lose that pretty colouring. So that's an introduction to scripting, and we have now written a shell script, and none of the more complicated things that we'll do with scripting over the next few days are really any different to what we've just done. We're just going to write some slightly more complicated bash to enable us to do some fancier things. But the beginnings of scripting is all right there in those 2 little scripts that we've written this afternoon. And so tomorrow we'll carry on with scripting, and we'll take a look at some more complicated features. So we'll have a look at variables, and if we get time, we will also take a look at, we'll also look at how to give arguments to scripts. Like you can give arguments to commands. We'll look at how to give arguments to scripts. And if we get time, we will look at writing a loop as well, which will be fun, I'm sure, for everybody. If we don't get time tomorrow, we're going to get plenty of time in the weeks to come. Okay, so that's me done for today. So I will sign off. I will sign off with what we will henceforth refer to as Disco Chick. There you go. So I'll leave it there, and I hope to see you all again tomorrow. Thanks for following along. Stay safe, keep well, and see you tomorrow at 4 p.m. Okay, bye everybody. Good night.